In this video, we're going to review one approach for creating a Maestro module of the bow for this hull. Typically, we use the watertight bulkheads as a starting point for the module boundaries. For this video, we're going to consider everything forward of the first watertight bulkhead as the bow module. So from this bulkhead forward. One of the things we'll need to decide first is how we want to build the module, whether to use strakes or to build it using quads and tries, or a combination of the two. Strakes are very useful for building large sections of the module quickly, but they have a limitation in that they are defined by endpoints, which are straight line segments from one end of the module to the other. Building from quads and tries, on the other hand, takes more effort, but it allows more freedom in defining the FE mesh. If we take a closer look at the bow, you'll see there's a fair amount of curvature we'll need to accommodate as we move forward, as well as a fairly unique stem shape. If we were to try and do this with the strakes in a single module from the tip of the bow back to the bulkhead, it'd be very difficult to capture this shape. We could, however, break this module into several smaller modules and transition from the strake-based definition to the quads and tries as we moved forward. Most Maestro models using strakes will have to transition at some point as you move forward into that more curved bow portion, but where exactly that transition happens is really up to the user. For purposes of this video, we're going to build the entire bow module out of the quads and tries, which will allow us to capture pretty much all of the shape and curvature for both the hull and the traces of the stiffeners on the hull. The procedure that we'll use is basically just to create a polygon mesh in Rhino that will then export and read into Maestro and assign properties to it. In terms of some of the features that we're going to need to capture in that mesh, we'll need nodes along all of the stiffener traces so that we'll be able to attach beams in the Maestro model. We'll also need nodes along any of these contact points where the frame touches the hull, as well as things like the girder and any of the lines defining features in the hull, such as the deck at edge or any of the chines or the stem. We'll start by creating the polygon mesh for the deck and hull plating, and then afterwards we'll use the defined nodes in those meshes to build inward to create these frames, as well as the centerline girder and this grillage. The stiffeners will just be modeled as beams in Maestro, so we won't need to model anything for them in Rhino other than the traces on the meshes for the plating of the deck and hull. In terms of the features that we'll need to capture in the mesh, we'll need nodes to define anywhere where we have a stiffener trace along the deck or hull. We'll also need nodes to define the contact points with the hull for any of the frames and any of the girders. The easiest way to do this would probably be to extract all of the feature lines that we want to use for creating these nodes and then intersect them with planes to create sort of a 3D mesh of points that we can connect to create the polygon mesh that we're going to use for our Maestro FE mesh. To start, let's create some cutting planes that we can use as reference geometry for breaking up the model into the modules that we want to create. So we'll create a plane surface that'll be able to cut the entire model, and then we can make copies of it and move it. We'll use the set point command to relocate it in the X direction and place it right where each of the watertight bulkheads is, as well as at each one of these frame locations. So we'll simply cut and paste and then run the set point command, and locate these planes. Now created all of our cutting planes and placed them on individual layers so they can easily be turned on and off as needed. You can see there's one major layer for cutting planes with two sublayers, one for the module boundaries, which as you see corresponds to the watertight bulkheads, and one for the bow frames, which if we zoom in on the profile view and toggle this layer on and off, you can see they correspond to the major and minor frames in the bow module. We've also created layers for endpoints. The endpoints layer will contain copies of any of the original geometry that we want to modify and use for creating our Maestro model. Under the endpoints layer, we've created sublayers for the hull and house, and at the moment, under the hull, we've created sublayers for each module. So these are the modules as divided by the watertight bulkheads, module 1 being the stern back here, and module 7 being the bow module that we're working on right now. Ideally, if we were setting this model up for building the entire ship, we would extract all of the curves and everything that we need for the entire hull. At the moment, we're only concerned with the bow, but we'll set it up as if we were creating the entire hull. The first thing we'll want to do is copy all of the longitudinal and deck stiffener traces. So we'll highlight those two layers and select all the objects on them. With all of our stiffener traces selected, we'll simply cut and paste. When we paste them back in, the copies will be on the same layer as the original, but while the copies are still highlighted, we can go into the Properties dialog and change the layer to the endpoints layer. Now, if we turn off our longitudinal and deck stiffeners, you can see they disappear from the model. But if we turn on the endpoints layer, you can see all of our copies of the stiffener traces are now in the endpoints layer. The other thing we'll need are all of the feature curves from the hull. So we'll need things like the decked edge, any of the chines in the hull, the trace of the stem, the chines defining the edges of the tunnel, and any girder contact points along the hull in the longitudinal direction. So if we were to hide the deck, we can see there's a girder running here that contacts both the cross structure, or the underside of the cross structure, and the deck. So we would want to extract that line as well, so that we would have it as a either a endpoint for a strake or a feature line that we can cut for creating our mesh in the bow area. To extract the feature lines from the hull, we'll use the Curve from Objects, Duplicate Edge, and just copy the edges of these surfaces. To make it a little easier to select, we'll hide some of these layers that we're not concerned with at the moment and just leave the hull and deck on. So now if we want to start extracting some of the hull curves, we can grab this chine and extract it. While it's still highlighted, let's go in and change the color of it. And we'll make all of these extracted curves red. So when we mix it in with all of the stiffener traces that we have, we'll be able to tell which curves were curves for the hull features and which were stiffener traces. Before we copy this over, or rather move it over to the endpoints layer, since cutting planes was selected, that's the layer that this curve was created on. But if we turn on our endpoints layer and grab all of these, since the endpoints from the deck house were in red already, let's make these all black. So we will select all of the extracted stiffener traces and make them black. Now we can grab the objects from the cutting layer, or cutting plane, and move it to the endpoints layer, and now all of these objects are on the endpoints layer. So we'll finish extracting the rest of those curves, and since the hull is symmetric, we can get rid of either the port or starboard side and just work on half the hull and mirror it. Since the deck house isn't, we would have to create the full deck house for the model. Jumping forward once again, you can see we've now extracted all of the hull feature curves, and they're highlighted in red. We have the stem profile, the deck edge curves, the various chines in the hull surface, The intersection curves between the longitudinal girder and the deck and underside of the cross structure, as well as the chines defining the edges of the tunnel and the hull. There's an additional curve in cyan, which is the intersection of the hull and deck with the center plane. This is because we're only modeling half of the hull in Rhino, and we'll mirror that in Maestro once it's been created. The house, on the other hand, since it's asymmetric, we've retained both the port and starboard sides for all of the stiffener traces and feature curves. The house curves have already been moved onto the house layer and can all be turned off simply by turning off that one layer. As for the remainder of the curves, they're all on the endpoints layer. So if we select all objects on the endpoints layer, you can see we have all of our curves. The next step would be to break them up and put them on their individual module layers. To do that, we'll simply join all the curves and then turn on our module boundaries and use the split command and the module boundaries as the splitting surfaces to break them up. And now, if we were to grab all of the curves between these modules, or between these boundaries, we can easily grab these curves and move them to their appropriate layer. Jumping ahead again, we've taken all of the hull lines and moved them onto their appropriate module layers. We'll make module 7, the bow module, our current layer, and start turning off the modules that we're not going to be creating at this time. You can see there are still a few vertical stiffeners shown on the model. These are all presently on the hull layer. If we select all of these objects, we can simply hide them, since we're not able to turn off the hull layer since it's the parent of the one we're working on at the moment. Our next step will be to take all of these hull curves and intersect them with the bow frames. This will generate all the points that we'll be using to create the deck and hull meshes. One thing I'd like to mention at this time is that there were a couple minor modifications made to a couple of the curves, and this is one of the reasons why it's nice to deal with just copies of the geometry rather than the originals. There were 5 curves that had very minor changes made. There are copies of the originals here in magenta, which we'll show. You can see one of the curves was slightly inboard of the hull, the other was slightly outboard. It wouldn't make much difference in terms of structures, but when you build the mesh, you can see a slight dent in the hull. The others were just minor trims, where you can see this line projects beyond the end of the hull, and the others very slightly went beyond the edge. I just wanted to mention this before we actually make the cuts to generate the points. So we'll hide those curves again, and now we can deal with just our stiffener traces and the hull geometry curves. If we turn on our bow frames, we can use the intersection of 2 sets to generate most of our points. So our first set will use all the cutting planes, and our second set of points will be all the lines. We turn off our cutting planes, and now we have most of the points that we'll need for generating our mesh. If we grab all of the curves touching the bulkhead here, I've already set the directions to be in the same direction, although I missed one there. So now they're all pointing forward. So now we can use the curve, mark curve start, and now we have all the intersections at the bulkhead as well. There are a few points down in here where we'll need to fill in. This is where the grillage was, and there are a couple other spots where we'll need to generate new curves, but for the time being we can start working on the deck and this after portion of the hull, since we have all of the points that we'll need for generating our mesh. We'll start with the deck. To make it a little easier to see what we're working on, we'll use clipping planes. So we'll create a clipping plane in the top view, and we'll flip the direction so it's only showing everything above it. We'll slide it up so that we only see the deck surface. we can go into Properties and also make that active on the top layer, so we get a good view over here as well. Now if we start building our mesh in here, you'll see that we're going to need some additional points in these areas, right here and here. The easiest way to do that is to probably take our deck and cut a section through it. So we'll select the deck, cut a section, and draw that line forward, and we'll change the color of these so that we know those are new cuts, not stiffener traces. And then we can turn off our deck layer again. Since Module 7 was the active layer, that's where these lines were created. Now we can grab those two lines, turn on our bow frames, and do the intersection of two sets again. Takes a second to refresh to get rid of the bow frames from the clipping plane. But now we have all of our points. Now this is really up to the user's preference as to how they want to build the mesh from these points. There are a number of different methods. In the mesh tools, you can individually, and actually if we limit our selection to points, you can individually start making mesh faces. And this may work well around some of the borders and areas where we'll need to do some detail work. And then by creating every other block, we can then use the add a face and start connecting them. This will save some clicking. Actually, we can also use the fill a mesh hole to create it, and then if it triangulated that mesh, you can get rid of you can merge it back into a quad. So that's one way of creating the mesh. Another would be to use polylines. So if we were to, from this point up to, say, here, create polylines through or across the deck. We grab all of these points, do polyline through points, create several of them, and now if we loft a surface through those polylines, and if we set it for straight sections, we can now delete those polylines if we want, since we don't need them anymore, or they can be left in the model. But I'll delete them for now. Now we can't create a mesh from a NURBS control polygon if it's a poly surface. So what we'll have to do first is explode that poly surface so it's a series of individual surfaces, and now we can create the mesh from the NURBS polygon. We go back in here, select the surfaces and delete them, and we're left with our mesh, which we can join into a single mesh now. And then you could create from that point forward, say from polylines for all of these, and generate actually from there, you could generate another set and work your way forward. and then just use the creating individual single mesh faces to fill in the edges around the curves here. So I've just created that next section using the polylines and lofting and then converting to a mesh. So now we'll need to fill in this area at the edge, and we can just create our own mesh faces in there and start using some of the mesh tools to create the rest of the mesh faces. And we would continue working our way forward. Now that the deck mesh is finished, we can start working on the hull. So we'll delete this clipping plane, and it looks like we have a good collection of points in this region here where we can do the same, use the same trick that we used on the deck, where we create polylines along these lengths and then loft surfaces between them. We can't use the stiffener traces because they're not polylines based on these points. If we turn on the points for them, you can see there's a lot more control points than what we want to use. We really just want polylines corresponding to these nodes. So I've created additional surfaces, Maestro and the Module 7 mesh. What we'll do is we can select all of the points and move them onto one of those layers. So let's move them onto the Module 7 meshes layer. And we can start working there. So these are roughly the points that we want, but you can see there's a number further forward. So we'll use clipping planes again to clean up the portion of the model we want to see. So we can start grabbing groups of points and use the polyline through points. And we'll make this clipping plane active in the perspective view also. So we have that one done. And this is the method we'll use for creating all of these lines from the center line down around the bottom and up most of the way up the outside of the shell. You can see when we get to this point we'll have to stop because we have a few stiffeners that stop short as this chine moves up the side of the hull. We can come down from the deck edge a few rows, but then we'll have to do something manually in this area to create that mesh. So I've just gone through and created all the curves for this portion of the hull from the back bulkhead to the clipping plane we created. If we select all of these curves, we should be able to just loft a surface through them. The gap between these two looks fairly large, so what we'll do is insert an additional curve between them. We can use the tween curves command to simply generate a new curve between these two. And if we were to turn on the points, you can see it has the same number of control points as the other curves. So we can try and create the loft in one shot and if it doesn't work, we'll do it in smaller sections, but it appears to give us the shape that we're looking for. So once we say OK to that, we can select this, but it's a poly surface as we saw before, so we'll have to explode it, and then we can create a mesh from the NURBS control polygon. If we select these surfaces, there are 64, and we do have a clipping plane active, so there could be something elsewhere. Let's make sure we're not... Okay, that's why there are so many surfaces in here. There are very small ones up top. And we can delete those surfaces, and now we're left with just meshes. We can select the meshes, deselect the top one, and join them. So now we have a single mesh representing this portion of the hull. We can do that same trick with the polylines to generate a mesh from here up to the deck. So now we've created those polylines, lofted a surface through them, and converted it to a mesh. But we still need to fill in this gap in here. It's not very large, so we'll just build it by hand. Actually, we can specify only grab points. And then start connecting meshes. And fill that full and convert those tris to quads. Now this would seem to indicate we have an issue with the mesh normal there, so we can simply unify the mesh normal, and now we have most of our hull mesh. If we delete the clipping plane, we can see how much further we have to do moving forward. In order to continue building the mesh moving forward, we'll need to create some additional nodes in the lower part of the hull here and some other areas. We'll turn on the hull, frames, and stiffener traces to get a better look at where we need the points. We'll need to create cuts along these horizontal plates in order to provide points where they can be attached. When we intersect them with the bow frames, all of the vertical plates will have nodes for us to build those frames. In the areas where there's no longitudinal structure we need to attach to, these section cuts can just be made to form a nice looking mesh. We'll do this the same way we did the cuts in the deck, where we select the structure and then use the section command and make a section cut through it. We can throw away the curve on the port side, and for the cuts that we make, we'll change these to cyan also, so we can differentiate between the stiffener traces and these new cuts. Skipping forward, we've now completed all of our section cuts through the hull. We've also intersected those curves with the bow frames to generate the required nodes we need in the areas where we were missing some points. To get a better view, we'll turn off the longitudinal stiffener traces and the frames. You can see we have all of our intersections with those horizontal plates, and those are both on the inner hull and the outer hull. Where the curves up above, they were only kept on the outer hull because we already had a pretty good point distribution from the longitudinal stiffeners in this area. There was one additional curve that was made on the center hull, and this was similar to what we did further aft, where we just created a polyline through the points above it and a polyline through the points on the center line, and used the tween curve command to create a curve bisecting those two. There was one other adjustment that was made, and that was to take the 2 points that were originally intersected with the stem and one of the bow planes and move them slightly up and down. Spreading them apart gives a better distribution of points in this area so that our quads are more uniform, and it also makes a pretty good approximation of what the stem shape would be in this area. Next, we'll start making the mesh in this area. This is really up to the user's preference in terms of how they want to do it. The lofting trick that we used earlier could be used again, but it would be in much smaller sections because in this area we don't have the uniformity of points that we did further aft. To make it a little easier to grab the points, we'll create a clipping plane. And I'm going to flip that around to just look at the outer hull here. And I'll move that back slightly so we can see the center plane points. I'm going to create some meshes and only select points. And it looks like it did not quite catch a point there, so we're going to create one at the end of that curve. Although we could have just snapped to the end point to create this mesh. Now we'll connect all of these meshes, and this would basically form the back end of this forward portion of the mesh. And the reason for doing this is to show how easy it will be to stitch these two meshes together. Since we need point-to-point connectivity, you can see we have some discontinuities in here. So what we'll do is join these two meshes and use some of the meshing tools, basically the split a mesh edge. So if we grab this edge, we can just snap on the point and it'll split this quad. And since we don't need 3 tries, we're better off with a quad and a single try. We can clean it up using the merge two mesh faces command. We'll simply do that for these additional edges. And we'll also need to do this on the other side. Now you can see these mesh edges weren't, or the points where it split weren't exactly on top of one another, so we will need to turn the points on and stitch these together manually by just dragging the points together. And now we can go and complete the bow mesh. Jumping ahead, we now have the deck and hull meshes created, but it's just a shell. We'll still need to create the internal frames and the center girder. If we look at the seam between the deck and the hull, we can see we have point-to-point connectivity, as well as along the stem between the inner and outer hulls. The area that we looked at earlier has also been stitched together, this transition between the longitudinal stiffeners and the horizontal plates. And you'll see a couple extra triangles that don't appear to be needed in the hull surface, but if we turn on the frames, you'll see that there's a small frame in here that needs to be accommodated. To generate those points, we just extracted the upper and lower edges of this frame and projected them onto the hull surface. So next we'll need to start on the center girder and framing. We can see that we'll need to tie together the frames and the center girder. So we'll need a point defining the top of the center girder so we can use it when we generate our frames. To do that, we'll hide this mesh to get a better view, and then we can either extract the border as we had done before with duplicate edge, but you can see there's quite a few segments in here. What may be better is to extract the entire border in one shot and this is a single curve, so what we can do is explode it, remove the pieces at the ends of the portion we want to keep, which is just the top of the center girder in the bow region, and join it all back together. Now we can delete the rest of the curve that we're not interested in. We still have the upper portion of the girder here, and we can delete those pieces that we removed to just be left with the top of the girder. And now we can intersect that curve with the bow frames and now we have points for the top of our girder. To start building our frames, we'll create some clipping planes to make it a little easier to see just the portion we're interested in. We'll make a second clipping plane and flip it and slide it back a little bit so that we can just see one frame. We'll select all of the meshes and hide them, so now we're just left with the points and the frame. To create the this inner edge, to generate some more points so we can start building our mesh, we'll extract the border of this frame and we can get rid of the outer curve since we already have all the mesh points on that outer hull. If we turn off the frame layer, we can see the curves we're left with. We won't need the port side, and we'll cut this one in half by creating a line down the center and trimming away the rest. We can mark these endpoints since we know we'll need those. And to generate the rest of these points on the interior of the frame, we'll select that curve that we just created and use the closest point projection, and we can start grabbing points and projecting them from the outer hull. We can then go along and use the mesh tools to start, missed one there, but to start building these frames. Missed that one also. I should have just selected points only. Make it a little easier to select these. and this is how we'll build up our frames. At the bottom, we'll see that we'll need to have that centerline girder tied in. Now we'll create additional points in here as needed to generate a mesh in this region. Jumping forward again, all of the internal structure has now been created. Each one of the frames was created as was just described, and the clipping planes were slid forward to isolate each frame so each one could be built individually. If we turn off the meshes, we'll get a better view of the frames that were created. And once the frames were built, we were able to add the horizontal plates and the centerline girder. If we turn on the frame layer and the center girder layer, we can see the comparison between the meshes we've built and the original surfaces. Our next step will be to create the aft bulkhead. To do this, we'll extract all the points from these meshes. We'll simply select the meshes and use the extract points command. We can now turn off the layers with the frames and the meshes and only keep the points at the bulkhead that we'll be building. We should select duplicates so we can throw away any duplicate points, and now we can build our mesh from these points. These are all the contact points that we'll need to match to tie into the existing mesh. The user can do this any way they like, whatever they're comfortable with in terms of creating the meshes. One method that we found to work fairly well is to create a polyline at the deck or the upper portion of the bulkhead you want to create, and then make a copy of it and use the set point command to translate that copy to the bottom of the bulkhead you want to build. Then, similar to the way we built the hull, we loft a surface between those two lines, and now we have nodes at each one of the points on the deck that we want. We can delete the original lines, and if we use the insert knot command in this surface, we can start creating knots vertically at the locations we want. And then create the mesh from this surface. If we delete the surface, we're now left with a mesh that's will tie in fairly closely to what we need on the hull. We can now delete some of these additional meshes that won't be needed, and then we would turn on the control points so that we can start moving these mesh points onto the hull points. When we're done, we'll have a bulkhead similar to this. Now that we've created all of our meshes, we can export them to polygon mesh files to be imported into Maestro. We could select all of them and export them as a single file, but when we read that into Maestro, they'll all come in a single module. To make it a little easier to assign properties in Maestro, we can export them in groups so that each group will come into a separate module in Maestro. We can assign the plating properties and then merge them all together into a single module. If we select the bulkhead first, we can export that one mesh as a PLY file, and we'll call it bow bulkhead. The other files in this folder contain the other various surfaces. The bow file contains the deck and the hull meshes. The bow centerline girder contains just the centerline girder we created. The bow frames contain all of the transverse framing inside the hull, and the bow horizontal plating contains just those few horizontal plates in the forward end of the catamaran hull. Now that we've exported all of our meshes, we can begin working on the stiffeners for the deck, hull plating, and the bulkhead. All of the beams for these stiffeners could be created in Maestro, but since we have these meshes available in Rhino, we can take advantage of a Rhino script that was written, which will export beams on a mesh surface. To start, we'll pull up the Rhino script, which is export Maestro beams, and load it. We have several options for creating the beams. The first is polyline in direction, which just takes a polyline in 3D space and a user-specified direction. It then creates the beam and saves it as a Maestro neutral file. Polyline on mesh will take a polyline defined by mesh vertices and the associated mesh, and it'll generate the beam using the mesh normal. Mesh in direction has two options. One, which just creates the polylines and leaves them so that the user can edit them and then use the polyline on mesh command later, or mesh in direction, which goes one step further and actually exports the beams. When you use mesh in direction for beams, it'll also give you the option of whether or not you want to keep the polylines for later use. Mesh direction in seed hasn't been implemented yet, so we won't discuss that now. For the bulkhead, we know we want our beams to run from the deck all the way down, so we'll use the mesh in direction beams and go through the full export process in one step. So we select the bulkhead mesh, and then we have to select a direction and then an angular tolerance. Now you can see the polylines where the beams are going to be exported, and we do have one on Centerline that we don't need. We also have one on the outboard hull that we don't need. It's very easy to delete these in Maestro, so we'll just go ahead and let it create those and delete them after we import into Maestro. You can also see that there are a couple of segments that didn't get created because the last segment on the mesh edge exceeded that 20-degree tolerance. So we'll have to add in these little beam segments in Maestro. But again, that's very easy to do. When we go to save the files, the beams for this bulkhead will be saved as bow bulkhead beams. When they're read into Maestro, this will be the module that they're read into. There are several other files that were created, and this was done similar to what we did with the meshes, so that the beams that we create on the hull and deck surfaces will be grouped into modules, making it a little easier to use the group properties assigned to change the beam types. We have the deck beams, which are just the beams up on the deck portion, the inner hull beams, which are the stiffeners on the inner hull surface, the outer hull beams, which are on the outer hull surface, and the lower hull beams, which are the beams below the chine on the catamaran hull. To create the polylines that we're going to use for exporting for the stiffener traces on the hull, we already know where those stiffener traces are. So let's isolate one section of the hull to work on, and we can turn on our stiffener traces. If we grab the mesh, we can extract the points from it and then hide the mesh. So we now have the points and the stiffener traces. If we look at the original stiffener traces and turn points on, just as before, these aren't polylines created from the vertices, these are entire curves. And what we really need are polylines created from the mesh vertices. So what we'll do is we'll lock that layer so that we can no longer select those lines, but we are able to select the points. So now we can grab a group of points, create a polyline through those points, and now we have our stiffener trace based on these vertices. If we turn off Module 7 layer, you can see there's our new stiffener trace. We've already gone through and created all of these, so if we delete these points and turn on the stiffener trace layers, these are all of the stiffener traces created from the mesh vertices. And we can turn our mesh back on. And you can see the stiffener traces on the hull. To export them, we would run our script again. We would use polyline on mesh. And if we, let's say, just wanted to export the lower hull, we would unselect all of these curves up above and then select the meshes to be used for the normals and save the file as our lower hull beams. Now that everything has been exported from Rhino, we can begin importing our bow module into Maestro. First, we'll import the meshes starting from the inside out so we can better see each thing as it's added. We'll start with the frames, and as you can see, the default units are meters. Our Rhino model was using millimeters, so we'll need to adjust that here. We'll also want to transform nodal coordinates since Rhino was working in positive Z up, and Maestro by default uses positive Y up. You can see all of our frames came in on a single module, and we can just begin importing the rest of those. It remembers which units we were using, so we just need to check the box for transforming coordinates, and now we have our centerline girder. Our horizontal plating, the deck and hull plating, and finally our bulkhead. If we toggle the endpoints on and off, we can turn off the nodes and just see the quads and tries. Next, we'll import the beams. These were saved as Maestro neutral files, and we'll start with the bulkhead beams. Again, we'll transform the nodal coordinates, and it's still using millimeters, so we're good there. Now the beams came in on the forward side of the bulkhead. If that's not where we want them, it's easy to flip the normals and move them to the back side of the bulkhead. We'll simply open a group dialog, add one of the beams, and add by type. So now all of the beam elements will get added to this group. And then we modify properties and flip the normal on all beams. And now our beams are on the back side of the bulkhead. As we mentioned earlier, we have an extra beam on the outside of the hull and on the center line and a little bit on the inner hull here. To delete those, we'll simply use the deletions dialog and quickly remove all of the beams that we don't want. We accidentally got a quad, so we can return that to the model and continue deleting our beams. It's another quad, and we'll put that back in and delete. Also, as we mentioned, we're missing a couple small beam segments here. Now, if we just look at the bulkhead and the beams, you can see it looks like there are nodes we can use to create these beams, but those nodes belong to the bulkhead, not the beams layer. If we just look at the beams, you can see we don't have any nodes to connect to if we try to build them in this module. So what we can do is we can merge these two together. Since we know they're going to be merged later, we can go ahead and merge them now, and that's a simple drag and drop in the parts tree. So we'll drag the beams onto the bulkhead, and now they're both in the same module. And if we go to create additional beam segments, we now have access to these nodes. Just to be safe, we'll renumber FE tags and then proceed to build those last beam segments. To make sure they match the adjacent ones, we'll start by selecting one of the existing beams and then create a new one so that all of its properties and direction will match. And then we'll create it on the end there, and then we'll create another one for the other missing segment. And now our bulkhead is complete. We can go ahead and import the other beam sections, the deck beams. We'll import the inner hull beams, and this will give a good example of how it used the normal of the mesh to generate these beams. Add the lower hull beams, and finally the outer hull beams. And as you can see, each one is on its own layer, making it a little easier if we wanted to modify the properties of each category of beam. So once the properties are modified, this should be pretty close to being a final Maestro model. But there are a couple features that are still missing, such as the combing around the inside of the frames, and also on the centerline girder. The flange on top of the girder is missing. To add those parts, what we can do is we'll make the bow frames our current part. We'll create a new beam, and we'll set the direction for it's in the X direction. We'll go ahead and create that beam. Now to quickly create the rest of these beams, we can use the nodal dialog. You open the groups dialog, go to the nodal tab, and start adding the nodes where you want to create similar beam segments, and then you can right click and say create beams, and it'll use the last created beam as the sort of source for creating the additional beams. We could also continue on and create those beams on the other frames. We'd do something similar on the centerline girder. We'd create one sample beam, but this one we'll put in the transverse direction. And then continue creating the beams. So once the properties have been assigned, and I guess plating would be another option there, we can say create or assign the deck plating by, I think we may need to refresh the graphics here. If we grab one quad from the deck, add by seed, we may need to renumber FE tags since we merged something. And now you could use the group modify and modify all this plating. We don't have anything defined at the moment, but it would be simple to go through and modify all the properties in the bow. Once they've all been modified, if you want to clean up the tree, everything can be merged into a single module very easily by just using the drag and drop like we did earlier. And once this has been done, the entire module can be mirrored so that we have both sides of our ship. And that should pretty much complete how we would build the bow module.